So I will be recording this lesson, and if you don't want to be recorded or have your voice recorded, just send me a chat and then we'll be able to check it out. So what we're going to do is go through sound. We only have 2 lessons yet, and then we will be all done except for the final exam in your lab. So anybody have any questions on anything for me?
The final isn't really on everything, right? It's just this last stuff.
The final's just on the last chapters, yeah.
And when is that going to be due?
Isn't it on the, I think it's got to be done by Sunday or Monday, I think. I can look. Hold on, I have it on my thing here. What's this, 213E? Is this you guys 213E or you guys 213A?
I think we're E.
It's Monday the 14th.
We're E.
Monday the 14th. So I can just open up our Zoom quiz lesson today. Look, there's Ken Upton. So I know this is you guys. So let's do the 14th. All right, so we didn't really need to have that recorded, but whatever. So we are going to go through the sound lesson. So sound is a disturbance, right? Just like we said, every wave is a disturbance that carries energy. So sound is a type of energy, sound energy. And you've all experienced it, right? A noise, and maybe you had a speaker up loud in your car and you could feel the pulses. That would be the sound energy. So the speed of sound changes in different materials. So sound will travel. We generally talk about sound traveling in air. 760 miles per hour is the speed of sound. You break the sound barrier if you go faster than that, and 343 meters per second would be the velocity in the SI. It's going to travel faster in materials where the atoms are tightly bound, like solids, because the atoms are already there hitting each other. So it doesn't take as much energy to get from one molecule to the next molecule or one atom to the next one. Whereas in a gas, the atoms are moving around randomly. So the wave hits one molecule and then it takes a little while to hit the next molecule and on down the line. Here are some different speeds of sounds. Here you can see air. This is at 0 degrees Celsius. And we'll show you how to convert that, but air 331. And then look over here in solids, how much faster it is. Steel 5960. That's fast, twice as fast as in air. These are the formulas to convert sound based on the temperature, because sound's going to travel better, or I should say sound travels faster at higher temperatures because the atoms already are moving faster. They have more kinetic energy, and the collisions are going to happen more often. So sound will move faster. The slower it is, the less sound, the colder it is, the slower sound will move. So this is your Kelvin conversion over here. And this one over here is your Celsius conversion. TC stands for temperature Celsius. This would be TK for temperature Kelvin, but you can see down here with the K, the Kelvin, in the denominator of that division sign. And you can do the square root because you don't have negative Kelvin, right? So 0 Kelvin is the low. So what is the speed of sound at 10 degrees Celsius and 20 degrees Celsius? We'll just do part A because part B is kind of boring. So we know the temperature Celsius is 10 degrees. So the velocity equals 331 plus, was it 0.06? I couldn't remember. I knew it, but I couldn't. I just wanted to make sure. Times 10. So 6 plus 331, 337 meters per second. And that is how you find the speed of sound. Pretty simple. Any questions there? No big whoop. So that's the easy part of the chapter, or the sections, I should say, is just to find the speed of sound. Read through that chapter, part of your book. There's some interesting stuff in there, just on how the sound works. We are going to talk about sound intensity next. This is a little bit trickier because we're going to have to use the logarithmic function, which I'm not sure you've used probably. Maybe you should have used it in algebra, but who knows if you did. And this has to do with frequency and intensity. So we know when we have a speaker, right, the top speaker is a high frequency and the small speaker is, or the big speaker is your small frequency. This is your bass and this is your treble up here, right? You guys are familiar with that. You probably got the big bass cannons in your trunk, shaking your car. So that's not how you spell bass, I don't think, is it? There's no R in there.
Yeah,
but anyway,
brass.
There's a lot of bass in the song Brass Monkey. So maybe that's what I was thinking about. But the high frequency means you have a small wavelength. Remember your formula, V equals lambda F. So high frequency, small wavelength, and then a small frequency has a large wavelength. They're inversely related. The perception of frequency is called pitch, and the perception of intensity is called loudness. This is measured in hertz. Loudness is measured in decibels, decibels. That's how that's spelled out, like that, decibels. So just some good times there. To find the intensity is a watt per meter squared, right? Power divided by area. So that's how we find our intensity. Power divided by area. And you can see as this gets further and further away, right? Closer, the smaller area, you're going to have a more intense sound. And it moves away. See where when you double the R radius, 2R, it's hard to see with all that writing down there. And then 3R, look how much the intensity goes down to a ninth. So think about your ear pods, right? You got your ear, there's your ear hole, and you put that pod in there, right? It goes directly into your ear, and right here is your eardrum. So when you're really close, having that AirPod in or whatever you got, your ear earbud or whatever you call them, right on your inside your ear, right on the thing, I can't think of the name now, but anyway, right on there, it's a really intense sound. It's super intense. So it's really bad to have these in for a long period of time. That's why after a period of time, you take those out, you feel that pressure go out of your ears, your eardrum. That was the word I was looking for. So it is much better for you to wear the over-the-ear headphones because they're further away. The source of the sound is further away from your ear. So you don't have to turn them up as loud. So it's just a little health tip for you as you go through your life. What's really bad is when you put AirPods in and then you mow the grass and then you turn them up over the mower, right? That's really, really bad for your ears. How we determine how bad it is for your ears, this is beta. Beta is your sound intensity level. And it's got that word intensity in there, so it gets confusing, but it's really essentially your sound level. And it's measured, I don't know why they have this in brackets, in decibels, that's the units. I don't know why they have that right there. So the formula is beta equals 10 log base 10 I over I naught, where I is watts per meter squared. So the idea here is this decibel, the sound level is based on intensity. So the higher the sound level, the more intense it is. It's a logarithmic scale. So a logarithmic scale is going to change as it goes up. You may not have used that much, but your calculator is automatically in base 10, logarithmic 10, log 10. So you don't have to change anything there. You just have to know how to use the button. and it's a function like sine, cosine, tangent. Those are functions. So is the logarithmic function. So essentially you just hit, if it's like 0.1, you just hit log or 0.1 log on your calculator. You just hit that button. And behind that button is going to be the 10 to the x button, right? Those are your two buttons on your calculator. This is the inverse function. So to get rid of the logarithmic function, to get rid of any function, you take the inverse function of the function. So I'm going to show you how to do that over here where I just erased. So if we have beta equals 10 log I over I naught, and we want to get I by itself, we got to get rid of this log. So we divide both sides by 10, beta over 10 equals log of I over I naught. Now to get rid of the log, we got to take this to the 10th power. 10 to the beta over 10 of 10 to the log I over I naught. Those are going to cancel, and now you're going to be left with I equals I naught 10 to the beta over 10. That's your formula to solve for I. Does that make sense? So you have this formula here that you need to know, and this formula up here. Those are your two formulas. You don't need to know how to go between them. You just need to know that those are the two formulas.
Is the one on the bottom I equals I naught times 10 to the beta
Sorry, I was
over
running out of room. Yeah,
1 to
10
the
to the beta over 10.
and I is intensity
Yes.
and I naught is what's that? Was I naught again?
That's a good question. That's what we're going to get to in the next problem. Next
oh.
slide. I naught is something, this right here is a constant value. It's the threshold of hearing. That's I naught. It's the lower limit of hearing. So you just need to know that value, and this is just a little bit of background on it. Here is the threshold of pain is 120 decibels, and this is just a chart from your book, but you can see after 120 decibels, that's an intensity of 1. That's when bad things start to happen to your ears. So you can look at this chart later. All right, we're gonna do a couple problems and get out of here, just like I promised at halftime for you. It says the warning tag on a mower states that it produces noise at a level of 91 decibels. What is this in watts per meter squared? So this is the intensity level. Excuse me. The intensity level is what we're looking for. This is beta. When you see decibels, that's beta. So we want to use the formula beta, or excuse me. I equals I naught 10 to the beta over 10. That's the formula we want to use here. So I equals 1 times 10 to the minus 12 times 10 to the 91 over 10. And we got to make sure we can put this in your our calculators. And I get 1.26 times 10 to the minus third. Watts per meter squared. Anybody have any questions there? All right. This one says a person has a hearing loss of 30 decibels for a particular frequency. What is the intensity that is heard at this frequency as an intensity of the threshold of pain? So the threshold of pain, remember, is equal to 120 decibels. What am I doing here? I think I got it written down. No, I just screwed it up. Oh, these crazy slides sometimes. All right, their threshold of pain is 120 decibels. So our intensity is 90 decibels. That's our intensity. So we want to find the intensity at this level. So it's pretty much the same as last time. I equals 1 or I naught times 10 to the beta over 10. And we get 1 times 10 to the minus third watts per meter squared. Any questions there? All right. Well, we got 2 more. I'll do this one with you, and then you guys get to do the next one. In a neighborhood challenge to see who can climb a tree the fastest, you are ready to climb. Your friends have surrounded you in a circle in a cheering section. Each individual alone would cause a sound intensity level of 80 decibels at your location. If the actual sound level at your location is 87 decibels, how many people are rooting for you? So the sum of the betas equals 87 decibels. Each individual beta is 80 decibels. You can't just add them up. What you're going to have to do is when we take the sum of the i's, the sum of the i's equal I naught times 10 to the beta 1 over 10 plus 10 times the beta 2 over 10 plus 10 to the beta to the nth over 10. That's how you would do that to find the sum of the betas, or the sum of the i's. And then the sum of the betas equals 10 log sum of the i's over I naught. So our goal is we have to figure out the sum of the i's first. That's what we need to do, figure out the sum of the i's. Then we can plug them in here. Well, I'll show you what to do. Now, we don't know. Our goal is to figure out how many people. So if we were to add them individually, this is how we would do it. But we also know if all of the i's are the same, we would just multiply all these out. So if this were 4, 4, 4, that's 12. So 3 times 4 is 12. So this value n is the number of people cheering. Because we know that they're all cheering at 80 decibels. So the first thing we want to do is figure out the sum of the i's. Or, foot fell asleep. To get the sum of the i's, we are going to manipulate this equation here, the sum of the beta equation. So we know that the sum of the i's equal I naught 10 to the sum of the betas over 10. Sum of the i's equal 10, 1 times 10 times 10 to the 87 over 10. So the sum of the i's equal. One times 10 to the minus 4th. Our goal is to find this n over here, this n right here, where I got the lines underneath it. So we're going to get rid of that. So we're going to say sum of the i's over I naught equals n times 10 to the sum of the betas over 10. I'm sorry, not the sum of the betas, the individual beta over 10. So that gives me 1 times 10 to the minus 4th divided by 1 times 10 to the minus 12 equals n times 10 to the 80 over 10. Put that in your calculator and see what n equals. I screwed up. I put 80 in here. I put 80. I didn't use 87. Son of a gun. I didn't get enough decimal places on there. This number's not right. I don't know how I got that number. I really screwed that number up. 8.7 to the 10th.
Couldn't we just divide the power of the 87 decibels by the power of the 80? And then
I
we
screwed
get how many people?
This number is wrong. This number is 5.01 times 10 to the 8th. Not to the 8th. 5.01 times 10 to the minus 4th. Oh my goodness, I'm losing my mind. I gotta put that in my calculator correctly. That would help. It's 5.01 times 10 to the minus 4. That's what I screwed up. So this here is 5.01. I'll just put it out here. There we go. Now it looks better. Sorry about that. So N comes out to be 5 people. Once I got my math right, once I learned how to use my calculator. 5 people, 5.01, but that 01 is just a hanger there. Doesn't really mean anything.
You can ignore a lot of the different constants and stuff they put in.
You did?
Well, you can. All I did to get the same answer was I took 10 to the 8.7 divided by 10 to the 8. And it gave
But
me
yeah.
5.
Well, when you look, when you do you can you don't have to figure out this math. You can do it all in one step if you want, but I wanted to do it slow, but I really butchered it. So yes. Does anybody else have any questions on this? Can you get it in your calculator? That's the key too. Can you put this in your calculator correctly?
I mean, when it gets to like 10 over the power of -12, my calculator gets to the point where it's like, it stops at like 10.
You got to put it in scientific notation
Yeah,
in the modes. You got to put it in science mode.
do that. Which one is science mode? Is that like grad or something?
No, it's SCI.
Yeah, I don't got that. I need a new calculator.
Use your phone for these problems. Right, your phone should put it in scientific notation, right? Anybody else have questions? All right, you guys try this one. All right, ready? So beta 1 is 60 decibels. Beta 2, 70 decibels. So we want to find the intensity. That's not the right formula. So the intensity is 1 times 10 to the minus 12 of 10 to the 60 over 10 plus 10 to the 70 over 10. Any questions there?
I got the same thing.
Good. Good, good. Anybody need more time here? Have anything need clarified? Ready for the quiz? All right, here goes nothing. All right, you guys have it all copied down? Switching out.